Hello there, welcome back to the Technology Innovation Hub. So it's going to be the 24th session on the Oracle architectural journey. Let me share this screen. We have been discussing system change number and we just went through the theoretical part of it. So this is what we just studied on the previous session. And I mentioned in that session it's difficult to deep dive system change number information using theory. So let's start the hands-on right away from this session. Okay, so for the hands-on I'll be using this particular document, and again since there are a lot of timing related information that we have to query from the database, so I'll be using a graphical user interface for that is SQL Developer. Most of you are familiar with it. Let's start. Now the very first thing is SCN is a huge number with two components. I think in the previous session also we mentioned that one. So SCN has SCN base and SCN wrap. So those are the main two components within SCN number. In a given SCN number, we are going to have two components, SCN base and SCN wrap. Now prior to 12C, the total length of both SCN wrap and SCN base represented with 48 bits, that means 6 bytes. It's a 6 byte 48 number, that's the total length. But in 12C they increased it to 64 actually, so 8 byte. But when it was in 6 byte number, out of 6 bytes, that is 48 bytes, out of the 48 bytes, wrap for the SCN wrap 16 bits were given, and for the SCN base 32 bits were given, that is 4 bytes. So 2 bytes for SCN wrapper and 4 bytes for SCN base, that is one. So the major part out of these two components, what is the major part? Major part is SCN base. So normally what's going to happen, SCN base will keep on increasing because we learned in the previous session every event in Oracle database is tracked using a system change number, every transaction. So for every transaction it has to assign, and it's a monotonically, chronologically. Monotonically, that means in sequence the number is getting increased, and it's chronologically, that means with the time it goes up. So that is what. At any given point Oracle cannot run out of SCN numbers, it cannot run out. So that's why there's a huge value, 2 to the power 32, it comes to around 4 billion. So what will happen if it hit this value? That means, okay, let's say for the SCN base only 32 bits are given, 4 bytes. So 2 to the power 32, 4 billion. So once it reaches this one, what Oracle will do, it will use SQL wrapper and it will increase SQL wrapper by 1 and it will reset this one. So again it will start from the beginning. So that is how it's going to work. So that's the logic behind it. Let's try to understand that one in detail with the hands-on. Components wise, SCN has two components, SCN base and SCN wrap. So that is what it is explained here. Okay, so enabling timing information. Okay, let's get into the hands-on, having that basic understanding. So let's get into the hands-on. Now the first thing is in SQL Developer, so you need to enable this timing information because by default it will give only the date, month and year information. Time information may not be there. So what you have to do, just go to SQL Developer, enable that detailed information. Under tools, preferences, you go to database and you have NLS. So under NLS you have database format. So this we have to add this one because default only this portion is there. So you have to add this hours, minutes and seconds information. So then click OK. So thereafter you get the full timing information when you query the date column from a table. So that is what the very first requirement. And the next thing is SMON SCN time, system monitor system change number time. This table is an internal table and it is not documented. So that also we need to understand because most of the SCN related information are not documented. So we need to do our own practical, our own research, our own hands-on, then we need to understand what's happening there really. So this table also not documented, but we can get more info because there's a script which creates this table. Anyway, by default the table is available under sys schema. So, S1 SEN time is a table that is filled by system monitor every 5 minutes. Yeah, every 5 minute record will be added to this particular table. Sometimes it can go less than 5 minutes, but most of the cases, yes, every 5 minutes a record will get added with the SEN information. And with timestamp and the current SEN, this table is not documented. Yeah, that's what I mentioned. And we can take a look at the script. If you, let's switch to the Linux environment, and if you go to that one, under this, we know the most of our scripts are located in rdbms admin directory. So if you just run a lsdt, just filter that one, and because the script starts from dt. So this is the script dt dtx translation spc bsq, basic SQL script. So if I just we just cat that one dtx. Now you will see script has certain other tables also, but our table is this create table S1 SEN, and these are the columns. You can see some description is there. Thread number, we know what is the thread number for the whole set of log files we are telling is a thread. Thread compatibility, and we have time MP, that is time this reason SEN represents, that is for the SEN time in information for SEN, time mapping MP. Yeah, okay. We have type date compatibility format, time DP, and the SEN wrapper and the base and the mappings. So likewise there are a set of columns in that, and we can just describe the table and see. So let's this table from here and let's describe that. So these are the columns there as we just located from the script: thread, time mapping, date compatibility, wrap, base, number mapping, and SEN mapping. So likewise, and we can simply just put the select star from the table just to get the whole information. Select star from, yeah, so we can get the latest information because this is somewhat old. So this one, yeah, okay. So today is 12/29. So now we have the information. You can see the thread is always yeah, it says 0. That's okay. Thread info, and this thread, actually thread should be 1 because we know that for redo thread it is 1, but here it says 0. If you go back to our column information, thread number, thread compatibility. Now this is not something 100% related to redo log thread. Actually it's just an indication to say that is the SEN thread. Doesn't matter because we don't have that much of information related to this table, but this is all we have at the moment. So even if you go up, check that one, local translation, global translation, yeah, we don't have. Yes. So anyway, normally now we know we describe the VDOLA log file that we just say describe VDOLA log. So we have the thread here, this thread, right? Select thread hash comma group from VDOLA log. I think group hash has to be there. So see, that's the thread. Normally in a single instance environment, the entire set of redo groups or redo files represent the thread. So that is always 1 in a single instance. This thread is always always 1 in a cluster environment only, depending on the number of instances. Instance 1 will have thread 1, instance 2 will have thread 2, instance 3 will have thread 3. But this thread is little bit different to that. Otherwise the value here should be 1 because this is thread 1. But this is just to give a indication about the SEN thread, which may be reset if the wrapper going to reset. But at the moment wrapper also 0, and if this becomes 1, this should become 1. Anyway, leave it for the time being. So that is that. Then the time mapping information as a number format, in number format, and this is the date format. You can see, and SEN wrapper is 0, and this is the SEN value at the moment for, yeah, this is also 12/29, somewhere down the time. I mean current time is not 13:04, current time is 6:43 p.m. But anyway, that's the information available at the moment in that particular table. S1 table, we can S28. So that's the latest information for the time being. Even if you code it back again, let's refresh it. Yeah, so that's the information it gives. The frequency of update, if you take a look at it, you can see 54, 50, 49, 55, 45, 49, 39, 45, Likewise, in nearly 5 minutes, every 5 minutes it has updated, and we can delete this table with caution, right, because deleting this table may have impact for flashback and then recovery as well, flashback, version query, those things. So with a risk, yes, we can truncate this table, and there are procedures given in my support. Likewise, so as of my table, this is the latest I am having at the moment. Yeah, so that is that. The table we can, further we can, let's take a look at other columns as well. So this is the base that represents the SCN, the ongoing SCN, and wrap is 0, and this is the number of mappings. Now we have 88 mappings. That means this particular SCN has been reused for 88 times number of mappings in this particular time frame. And if you take a look at this one, this time SCN mapping, and this is in hexadecimal, and you can separate these even though it represents as a single line. Now FA, if you go to this, you can see this 7/9 number ends at 0. So this is one segment after 0, and again starts again at the end of 0 another segment, again at the end of 0 another segment. So likewise, we can identify different segments in this particular column, and if you want, we can interpret back. We can extract the SCN base and the wrap from this number as well if required, but anyway it is given here, that is fine. So for the time being, just keep that information with regard to that table. And here we have queried that table, select wrap. Okay, now we queried that one, less than 10 is fine, can restrict the number of rows, select star. Here we did that one. Okay, so that is about that table. And let me take a break here. I am not going to get into more details in a single session related to this SCN. Let's have smaller sessions. So let me continue the next session in the this practical in the next session. So I will meet you soon back. Okay, have a great time. Right, bye bye.